Hello, 8th grade. Today we're going to be talking about how to simplify some radical expressions, totally tubular, etc. What this means is not like it's rad, like it's awesome. What radical is the sign for square roots. So what we're going to be doing today is simplifying some expressions involving square roots, and it's actually not as hard as it sounds. There's basically three rules we're going to be using, and the first two are the same. So the first one here is that if I have two square roots, the square root of a number and a square root of another number, that's the same as the square roots multiplied together. Just so you kind of see what that looks like, I'll put examples down here. The square root of 3 times the square root of 5 is going to be equal to the square root of 15, which is pretty easy to see. 3 times 5 is 15, so if you have a multiplication outside the square roots, you can combine them together, and it works out. That's nice. An example for the second one would be that if we have the square root of 15, if I wanted to, I could rewrite it as the square root of 3 times the square root of 5. And that works out pretty well too. This one right here is the one we're going to be using most because it lets us factor, essentially, our square roots and do some more interesting things with them. Our last one right here is going to be that if I have the square root of a number like 3 multiplied by the square root of 3, that's just going to be 3. And the reason that works, if we look up to our first one right here, and we use this, square root of 3 times square root of 3 would be the square root of 9, and the square root of 9 is 3, which means we should be all good to go. So we're just going to continue down this and see what all we can do with these three rules. And the first problem I want to try is to find the square root of 225. The square root of 225, you might have seen this on the poster in my classroom, but I want to try it again just because using some of this new information we have. So I said we can basically factor these things, so that's exactly what I'm going to do. I'm going to factor 225. I can see that it ends in a 5, so I know I should be able to divide it by that. And if I do divide it by 5, I will get 45. So it's 5 times 45, 5 is a prime, so I leave it. 45 becomes 5 times 9, and 9 becomes 3 times 3. So what I have now is that the square root of 225 is going to be equal to the square root of 5 times the square root of 5 times the square root of 3 times the square root of 3. So we started way up here, did a factor tree, and all those factors basically just got their own radicals. Now that we have this, we can use our third rule. We have the square root of 5 times the square root of 5 here. Well, that's just a 5. Square root of 3 times the square root of 3, it's just a 3. And 5 times 3 is going to be equal to 15. So the square root of 225 is going to be 15. And this is a way we can kind of simplify all of these and find the square roots even when they're really big numbers that would normally be difficult to find. That being said, sometimes we're not going to be able to find perfect square roots of everything, which is kind of sad, but that's okay. So I want to give you an example of that with the square root of 72. So if I have the square root of 72, I'm going to do the same thing with my strategy here. I'm going to factor it, and 72 becomes, let's see, that'll be 9 and 8. 9 can be 3 and 3. 8 is 4 and 2, and 4 is 2 and 2. So that's a whole bunch of factors there. So I'm going to turn my square root of 72, let me keep that on the screen, as being square root of 72 equals the square root of 3 times the square root of 3 times the square root of 2 times the square root of 2 times the square root of 2. So again, all I did here was took this number, I factored it, and then all those factors came down here inside their own radical. So I'm going to use my third rule again. I have square root of 3 times square root of 3. That's going to be 3 times square root of 2 times square root of 2 is going to be 2 times, and I have the square root of 2 at the end. That's just going to have to stay there. So I can rewrite this as 6 times the square root of 2, which a lot of times we prefer to write over square root of 72. This is what we would call a simplified radical, when we've taken everything out of it that we can, and we have a number inside here that we can't factor anymore, or that factoring doesn't do anything for us. And that is pretty much it. We can keep going a little bit. I want to do a couple more examples. So if we have variables in this, you all knew variables were going to happen. That's okay. I can have something like the square root of 81 x to the 4th y cubed. And factoring this, we factored these things before. I have 81 x to the 4th y cubed. This becomes x to the 4th and y cubed. Sorry, that should not say 8y, it should say 81. And my 81 factors into 9 and 9, which turns into a whole bunch of 3's. X to the 4th is going to be 4 different x's, x, 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 and y cubed is going to be 3 different y's. Y, y, y. Now that I have all of that, I can rewrite square root of 81 x to the 4th y cubed as the square root of 3, which is this one, times the square root of 3, times the square root of 3, times the square root of 3, times the square root of x, root x, root x, root x, root y, root y, root y. And that's a nice little chain of things for me to deal with. But going through this, root 3 times root 3, it's going to give me 3. Root 3 times root 3 is 3. Root x and root x is x. Root x and root x is x. Root y and root y is y. And then I have this awkward square root of y at the end. Multiplying all these together, 3 times 3 is going to be 9. X times x is x squared. Y, root y. And this would be the simplified way of doing this. But real quick, I want to look one more time at the original problem and our answer. So I have the square root of 81 x to the 4th y cubed equals 9 x squared y root y. So if we look, we know that the square root of 81 is 9, so we could have just pulled that out. X to the 4th, if we half that number right here, we get a 2. And if we half 3, we get 1.5. So we end up with 1y, and then the half of a y ends up looking like the square root. Would be kind of a faster way of doing it if you want to just try to do it intuitively right off the bat. If not, the long way of making the factors works just fine, and we can stick with that. So I want to try one more problem like this where I show you guys it intuitively one more time. So if I have 36 x to the 7th y to the 8th, I definitely do not want to have to write out all these square roots of x and y. So I'm going to square root that. What I can do is I can say, well, the square root of 36 is 6, so I can pull that out. Half of 7 is going to be 3.5. So I'm going to have x cubed root x, and half of 8 is 4, so that would be y to the power of 4. And that would be how I would simplify this equation. And again, if you want to go through the long way and factor everything out and square it like that, it works just fine. You'll get the exact same answer. But there's also this kind of fast, intuitive way of doing it where if you look at a square root, you can more or less figure out immediately what this answer is going to be. And whichever way you are more comfortable with is the way I'd encourage you to do it. Just please make sure that you do that lesson practice. I think there are 8 problems in that today. So if you can do those 8 problems, I take it back, there are 7 problems. 7 problems in the lesson practice for tomorrow, and I will see you all then. Toodaloo.